So under the topic asymptotes, we have the next problem here. Find the asymptotes of the given curve. Now this problem will be a little different because this one problem is going to have both parallel asymptotes as well as oblique asymptotes. Let us see that now. First step is we have to check for the degree of the equation. So the highest degree is 3. So the number of asymptotes, that is the maximum number of asymptotes for the given curve, will be equal to 3. So number of asymptotes for the given curve will be equal to 3. So now we have to find all the 3 asymptotes. First we have to check whether parallel asymptotes exist for this equation or not. For which, what is the maximum degree? It is 3. We have to check the coefficient of x cube in this given curve, whether it exists or not. So if we check, we have x cube term in this equation whose coefficient is 1. So therefore there exists a coefficient of x cube, which implies that there is no parallel asymptote to x-axis. So if the coefficient exists, then there will be no parallel asymptotes. If it does not exist, then there will be a parallel asymptote to x-axis. But if we check here, we have the coefficient of x cube to be equal to 1. So therefore, there is no parallel asymptote to x-axis. So let us write that now. In a similar way, we have to check for y cube, whether there exists a coefficient for y cube in this equation. So now if you check here, there is no y cube term in this equation, which means that the coefficient of y cube is 0. So because it is 0, there exists a parallel asymptote to y-axis. So there exists an asymptote parallel to y-axis. Now we have to find that asymptote which is parallel to y-axis. How we will be finding it? We will see what is the highest degree of y in the given equation. So if you check, the degree of y here is 1. The degree of y here is 2. And here we have a y whose degree is 1. So highest degree for y is what? 2. We have to take the coefficient of the highest degree of y and equate it to 0. Now what is the coefficient of y square? It is x. So the asymptote parallel to y-axis will be x equal to 0. So in order to find the asymptote parallel to y-axis, we have to equate the coefficient of highest power of y in the given equation to 0. So now we observed that the highest power of y is 2 and its coefficient is x. Therefore, x equal to 0 is the asymptote parallel to y-axis. So we have found one of the asymptote. Now this is an equation of degree 3. That is, the number of asymptotes, maximum number of asymptotes will be 3. Out of which one of the asymptote is parallel to y-axis, which we have written here. So x equal to 0 is one of the asymptote. Now we have to find the remaining 2 asymptotes. So the remaining 2 asymptotes will be oblique asymptotes. So what will be the equation of the asymptote in that case? We have already seen that the equation of the asymptote is y is equal to mx plus c. Now because we have 2 asymptotes, the equations will be y equal to m1x plus c1 and y is equal to m2x plus c2 are the equation of 2 asymptotes for the given curve. Now we shall find the value of m1 and m2 and using that we shall find the corresponding value of c1 and c2. Now how to find the value of m? In order to find the value of m, first we have to take and write the highest degree terms. So highest degree is 3. So what are the highest degree terms in the given equation? Now if we check here, the highest degree for this term is 3. And for this is, for x it is 2, for y it is 1. And together it will be 3. And for this is also x is 1 and y is 2. Together it is 3. So we observe that all these 3 terms is of degree 3. And these 2 terms is of degree 2. And this is a constant term. So now in that case, the highest degree is 3. And so we will be having these 3 terms with degree 3. So we can take that and write here. So that will be equal to x cube plus 2x squared y plus xy squared. Now in this we have to put x is equal to 1 and m is equal to y, so that we get phi 3 of m. So phi 3 of m will be equal to, if you put x as 1, it will be 1 plus 2m plus x is 1. So here you will have m square. So this is phi 3 of m. Now we have to find the value of m, for which we have to equate phi 3 of m to be equal to 0. For which we have to equate these three terms to be equal to 0. Let me write it in the order of the powers. So first I am writing m squared plus 2m plus 1 is equal to 0. Now we have to find the roots for this quadratic equation. We observe that this is in the form a squared plus 2ab plus b squared, where the value of a is equal to m and the value of b is equal to 1. So this will be actually m plus 1 the whole square is equal to 0, because we know that when we expand it, it will be m squared plus 2 into m into 1, which is 2m, plus 1, which is 1 square actually. So we can write this as m plus 1 the whole square is equal to 0, from which we get the value of m to be equal to minus 1 comma minus 1, because we have a square here. It is m plus 1 into m plus 1. So two values of m we will have, so which is minus 1 and minus 1, and we see that these two values are equal roots. So whenever we have equal roots, the formula to find the value of c will be given by this formula, where the value of n is what? 3. So in particular, the formula will be this. So now we shall use this formula and we shall find the value of c, for which we have to find phi 3 double dash of m, phi 2 dash of m and phi 1 of m. Already we have phi 3 of m over here. If you see here, we have phi 3 of m. Using this phi 3 of m, we shall find phi 3 dash of m and phi 3 double dash of m and substitute here. So let me show that now. So what is phi 3 of m? It is here 1 plus 2m plus m square. So let us take that and write here. So phi 3 of m is equal to 1 plus 2m plus m square. Now using this, we actually need phi 3 double dash of m. So from this we obtain phi 3 dash of m to be equal to, when you differentiate 1 it is 0, when you differentiate 2m it is 2, plus when you differentiate m squared it will be 2m. Then again we have to differentiate this. So phi 3 double dash of m is equal to, when you differentiate 2 it will be 0, when you differentiate 2m it is 2 into 1, so 2. So this is phi 3 double dash of m. In a similar way, we have to find phi 2 dash of m, for which first we have to write phi 2 of x comma y, that is all those terms with degree 2. So if you take the curve, what are the terms with degree 2? I have already given here. Minus x squared minus xy. You should take along with the sign, that is very important. So minus x squared minus xy. So we shall take that and write here minus x squared minus xy. Now in this you should put x is equal to 1 and y is equal to m in order to get phi 2 of m. So that will be equal to, when you put x as 1 here, 1 squared, so it will be minus 1, and here because we have this minus outside the square, so and then minus x is 1 and y is m, so it will be m. So minus 1 minus m. Now we have to find phi 2 dash of m from this, which will be equal to, when you differentiate minus 1 it will be 0, when you differentiate m it is 1, so we have a negative sign here, so this will be minus 1. And then we have to write phi 1 of m. So when we see what will be phi 1 of m, it will be those terms with degree 1. So when you check in the given curve, this is a constant term. We do not have terms with degree 1. So when we don't have the terms, we should take it as 0. So phi 1 of m is 0. Now we have to substitute phi 3 double dash of m, phi 2 dash of m and phi 1 of m in this equation and evaluate the value of c. So what we will get is c squared by 2 factorial is 2 only actually. So 2 and then phi 3 double dash of m. So what is phi 3 double dash of m? It is 2. So multiplied with 2 plus c multiplied with phi 2 dash of m. What is phi 2 dash of m? It is minus 1. So minus 1 plus phi 1 of m. What is phi 1 of m? It will be 0. So anyway, that's going to be 0. Now this will be, this 2 and this 2 gets cancelled, and so you get c squared plus into minus minus c is equal to 0. We can take one of the c common in this, and so we will get c minus 1 in the bracket is equal to 0, from which we will get c to be equal to 0, and c minus 1 equal to 0 will imply us that c is equal to 1. So the other two values of c are c equal to 0 and c equal to 1. Now we have to substitute this here in this equation, that is in this equation of the asymptote, and find the two asymptotes. When m is equal to one of the value of m, that is when m1 is equal to minus 1, and if we take c as 0, what will be the equation? Y is equal to m1x, so minus x plus 0 anyway. So from this, if you bring this minus x to the left, it will be x plus y equal to 0. This is the equation of the asymptote when m is equal to minus 1 and when c is equal to 0. And also we have another value of c, but the value of m2 is same only, which is minus 1. And what is the other value of c? It is 1. So c is equal to 1. So we will be getting y is equal to m2x, so minus x plus c2. So this is c1, this is c2. So plus c2 is 1, so plus 1. So from this we get the equation of the asymptote as, bringing this minus x to the left, it will be x plus y, and when this plus 1 comes to the left, it becomes minus 1 is equal to 0. So this is the equation of the asymptote when c is equals to 1. So hence the equation of the asymptotes are, the first asymptote that we found was here, that is x is equal to 0 is the first asymptote. So the equation of the asymptotes are x equal to 0, and the second asymptote is this, which is x plus y is equal to 0, and the third asymptote is x plus y minus 1 is equal to 0. So this problem gives us an example for equations having both parallel asymptotes as well as oblique asymptotes, because in the previous problems that we dealt with had either parallel asymptotes or oblique asymptotes only. But in this problem we observed that this given equation has three asymptotes, out of which one of the asymptote is parallel asymptote and the other two asymptotes are oblique asymptotes. So hope you have understood this problem. Thank you.